Good morning, students. We are learning fourth geometric transformation as a reflection, or it is also called as a mirror. So, what is the purpose of this reflection or geometric transformation? It is used to reflect a geometric entity about any axis. It may be x or y axis, it may be z axis. For three-dimensional entity, you can reflect or mirror about origin, okay, then about a line y is equals to x and so on. Means we can reflect half portion of a geometrical model about origin or about y-axis, x-axis, etc. Means this particular geometric transformation is used for editing or for developing a symmetrical objects. So there are 5 cases. First case is reflection about x-axis. First case. Reflection about x-axis. Then second case, reflection about y-axis. Then third case we will see is a reflection about origin. Then fourth case we will see is a reflection about a line y is equals to x. So first case we will see is, let us draw coordinate axis. So this x-axis, y-axis. So we'll consider a geometric entity, suppose a line PQ having coordinates x1, y1 and x2, y2. Now we are going to reflect this particular entity about this x-axis, means about this axis. So this particular distance will be the same distance, and this much amount of distance. Here the point you will get is so this will be the P dash, so reflected point, and this is O dash. So reflection about this x-axis means what? This distance here is plus y, and this is minus y, this distance. Again, this distance or distance from y-axis or along x-axis, this distance will be same here also and here also. So this distance will be same, x. Now here our aim is to find this P dash or Q dash. For sake of convenience, consider a point P only. So for point P, this x dash, this particular distance for reflected point, x dash will be x only because the same distance, and y dash will be this minus y. So in the matrix form, we can write this x dash y dash is equals to this is our original point. Here x dash equals to x means 1, 0 and 0 minus 1. And this particular matrix can be denoted by n about x axis, mirror about x axis. We can denote it as. See here, if we are multiplying these two matrices, you will get these two equations. 1 into x, so x dash equals to x. Y dash equals to 0 into x, 0 minus 1. So second equation we will get. Similarly, for the second case, we are reflecting the entity about y-axis. So consider the geometric entity line EQ with endpoints. So we are reflecting about y-axis. So this particular distance, again this distance, here somewhere you will get. So this one is P dash and Q dash. We are reflecting this particular entity about this y-axis. So this one is the original entity, this one is the reflected entity. So anybody can tell, see here, this distance means distance along y-axis will be same distance. And what about the x? See here, this one is positive x. For P dash, that x dash is equals to minus x because towards the negative side. So x dash is equals to minus x in this case and y dash equals to y. Therefore this matrix about y-axis becomes minus 1, 0 and 0, 1. And this one is x and y. So we can write mirror about y is equals to, this is the reflection matrix. This one is x dash y dash, or we can say P dash equals to mirror about y, and this one is original point. Same mistake I have done here. Actually this is the P dash. So P dash we can write here as this particular matrix M or reflection matrix about x-axis, and this one is the original point. These two cases we have seen. Now we will proceed for third case. So third case is reflection about origin. So here we will consider a point, only single point. having coordinates X, Y, and suppose this particular point is getting reflected about this origin. So definitely this particular point or reflected point will be in the third quadrant. So we can say this is the original point or entity, and this one is the reflected point. Reflected point. So P dash. Definitely the coordinates will be minus x and minus y, or x dash and y dash. So here we can write this x dash equals to minus x and y dash equals to minus y. So we can write x dash y dash is equals to minus 1 0 and 0 minus 1 x and y. So we can write this p dash is equals to this particular matrix we can denote about origin, mirror about origin, and this one is. Similarly, we can find a fourth case. What is fourth case? A reflection of entity. It may be found in this case about a line y is equal to x. So consider now we are knowing the equation of line y is equal to x. So this x-axis, y-axis, y is equal to x. If we are putting the standard form, here value of m is 1. Again, c is the y-intercept, which is 0 in this case, 0, and this one is 1. That's why y is equal to x is the line passing through the origin. So this is the line. This is the line having equation y is equal to x passing through the origin, and we are going to reflect a line or entity about this particular line. So this one is the original line, and this one is the reflected line. Original line, reflected line. Now for this, the conditions are from this equation. X dash equals to y and y dash equals to x. X dash equals to y and y dash equals to x. So the matrix becomes x dash y dash is equals to 0 1 and 1 0, x and y. So p dash you can write as mirror about line y is equals to x and p. So this one is the reflection matrix about line y is equals to x. So this is all about the reflection